All right, so I'm going to talk about performance monitoring and our Strong Agent module that we use to monitor and show some of the dashboard that we use to display the data that we get out of that. I don't have slides. I'm going to show some of the basic configuration that you use to set it up in an app. And I'm going to use the StrongLoop Suite example app, which I've already created here, so we don't have to sort of watch that happen. But you can create these sample apps just with SLC example. But that we've already done here. To configure any of these apps to use StrongOps, which is the monitoring platform we have, you would do SLC StrongOps, and you provide an email address. In this case, I'm going to use the demo account. Oh, that's the old one. And what this does is write some API keys to strongloop.com. So just strongloop.json. So here you can see it's put in my actual name, the user key, which is the API key that it uses to call home with. And the actual app that we've generated here comes pre-populated with the call to Strong Agent, which is this bit right here. And that's all you need to start using the Strong Agent module, and it'll start reporting back. So, I'm going to run this app, and we'll take a quick look at what it's doing. It tells you Strong Agent is profiling. If it wasn't configured properly, it'll give you a little message there to tell you that. So this is the actual example app that gets generated, which I'm sure you'll probably see more of shortly, depending on who's doing which demos. So I'm just going to make a couple of API calls without getting into too much of what this app is doing, and then hop over to the dashboard so we can see some of this data that gets reported back. So let's just refresh this. Okay, so this is the dashboard. You've got a picker here to select the different apps that report in. What we do is we group each app by app name. So if you've got multiple processes that are all running under the same named app, they'll actually show up with aggregate data on the dashboard. You can uncheck this all processes and pick a particular process ID to drill down, which is going to not work for me right now because it's a demo. But this view will show you aggregate data for all the processes that are running under that name. And then we've got some filters here to pick the different charts that I'll talk about here. So this app is really only doing two things, HTTP and calls to a MongoDB database. So you can see those times here. I did some load earlier so we could see a bit more data on that. You can kill these series, drill down to the details here. And this is average time over the last minute for each one of these tiers. So we have a number of instrumentation modules called probes for each of the third-party libraries. So for each of the databases, we have a probe that will go and get you wall time for the external calls that get made to via HTTP or MongoDB. We also support Postgres, MySQL, LevelDB, and Memcached, and Redis as well. The slow endpoints in databases just shows actual transactions that happened. So you can see some of the things that got made externally, requests from this app. You can drill down to those here and see the actual call that it made and the wall time for that call. And you can also see the MongoDB calls that got made. And here, when you mouse over this, you can actually see the query that it made as well. Okay. CPU usage is very low. This app's not doing much, but this is, again, pretty typical stuff here. User and system time for that process, aggregated across all the processes, actually, when that checkbox is checked. Heap size, you've got your heap and your RSS. There should be V8 full GC line 2, but that's not there. Concurrent connections shows you throughput and the number of connections. Throughput is going to be the connections per second averaged for that minute, and the actual connection number is just a spot check for the number of connections at that time to that server. The event loop stuff is using a UVMon module that's doing native checks to see how long each event loop is taking. So you can see the slowest event loop time and the event loop average. And that's done at the native level, so we've got pretty good numbers on that. So that's all the stuff that was for that particular app. I'm going to show another app that I have set up to give a bit more data. So this guy is hitting all the different databases. So if you had different tiers that are all instrumented, you can see how all of those are affecting performance here. So you could look for spikes in this stack chart. This app is kind of contrived to do, memcached, MongoDB, MySQL, and Redis calls. Probably not your typical app, but illustrates all the different modules we have. And here we can see the slowest requests that have happened, and this lets you do a bit of a drill down too. So this is an incoming request to the route post, which is just doing all the calls that we saw above. But what this lets us do is actually break this down to the pieces that it called out to. So we can see that this particular route basically went out in parallel to MongoDB, MySQL, and memcached. The MySQL call then, when that came back, called out to Redis and an external HTTP call too. And here you can kind of see like if your transaction was slow, like if this URL is performing slowly for users or over time, you can see exactly where that slowdown is happening. Now this won't include asynchronous calls in between the stuff, so this is just some transaction stitching that we're doing based on the modules and the probes that we already have. So only the stuff that we've already instrumented will show up here. But as we add more stuff over time, you can get a bigger and clearer picture of the transaction as it's being put together. Okay, so that was that. Another piece of the slowest endpoints in databases is the external calls. So we looked into this at the other one, but here we can see, because we've got more database calls going out, you can see all the SQL calls, which are really exciting things like sleep.01 and sleep.014. So realistically, these would be your top 10 slowest performing database calls as we've instrumented them. And it's only wall time right now, so it's worth noting that we are including pooling time. So if you're waiting for a connection, that's actually going to be part of this. One of the things going forward that we want to do is add a separate tier for getting those pooling times, and then you can see where the performance hit is between pooling or actual database usage. And yeah, so those are the basic charts that we have right now. One of the pieces I'm going to show is CPU profiler data. I've preloaded here. So this is run just, you pick the app name you want to profile, you pick the process, you run it, and then you stop it. So this isn't something that you'd leave running all the time. It's profiling specific for an event that you want to try and capture. And this shows you everything that's happening in the CPU profile data. So it's the similar data that you would see if you're using this in Chrome DevTools. The data is similar. We chose to render it in this segmented pie chart so you could sort of see the breakdown and the hierarchy here. So you can see, obviously 100% of the time is spent en route. Most of the time, and this is spent in the program, but then you can start to see where the actual application code is happening on ReadNet, tick callback, going into push stream readable, and you can see the line numbers as well too. We've got some tuning stuff here that might be a little bit hard to read from there, but you can right now it's set to collapse the call chains with only a single child just to make the data a bit more readable, but you can see the whole hierarchy like this. We need a bit of a zoom feature on this. There's some UI issues, but you can then drill down further and further and further and see exactly where the time is being spent while you were doing this profile. And yeah, you can get right down to some of the application code here. So this is our Uhura module connecting to the collector. This is actually profiling the process that's collecting data from the agents. Yeah, so that's the CPU profiling. And now I'm going to show you some things in increasingly or decreasingly order of brokenness, because some of this is work in progress, some of it is just not quite ready yet, but I thought I'd show it anyways to kind of show what the roadmap is looking like and some of the things we want to do with this. So the original use for the StrongOps was just monitoring, and some of what we want to get into is more of the operational stuff. So the least ready one is really just a screenshot of some of the cluster control stuff that's going to go into the dashboard. So the stuff that Sam showed us earlier, where you can scale your cluster up and down, the control for that is actually going to go into the dashboard, the StrongOps dashboard. And your agent, your Nodeflow agent, will be able to report back, or your Strong agent will be able to report back the size of the cluster that's currently set, and you can send through a control channel scaling data back down to that process, and it'll scale your cluster up or down. So that's coming soon. Alert system is a work in progress right now, but I'll show you how it's going to work. So this is running locally. Any of the data that we're collecting, we're also going to analyze for alerts. So you create an alert by clicking on this little exclamation mark, and you're given the series that chart is actually watching. So you can pick system or user CPU time, a threshold, and then the duration in minutes. So I've already made one of these. You can see here in the alerts, it'll show the status of that alert right now. So this alert, this first one here, was monitoring concurrent connections. So it's concurrent connections greater than 5 for a small number of minutes. And then the actual alerts that have fired show up as a table down here. Now, right now, they don't go past the accumulating state. Like I said, this is a work in progress. But the idea being that once the alert starts accumulating and it gets past that threshold, you're going to get an email. You're going to get a webhook that you can fire other events off of from that. These are fully editable from here at any time. Same fields. You can delete it. You can clear the alerts. This one's grayed out because we're actually tracking if the alert happened on a process that isn't running anymore. So we keep session data on all of the connected processes. And if it's not running, we know that this is, it was alerting, but that process is no longer running. We can maybe auto-clear some of this stuff out. We'll be looking for feedback on this. This one was set for CPU data. Process is running, so all that data is being tracked there. And again, once the accumulation period gets passed, it will send an email out and also fire a webhook, so you can fire off third-party pieces if you want to from these alerts. Some of the stuff we want to do with this is going to involve the scaling stuff as well too. So we're going to create events where you can trigger scaling events based off the alerting, so you can scale up if you have CPU usage that you need to scale on, or number of connections that you need to scale on. Okay, I'm going to take a look at the Heap Profiler. And this is going to take, it's similar to the CPU Profiler, where you pick your application and your process, and then you start it and stop it. We'll start this running here and cross our fingers and hope we get some data. The first chart will give us the physical size for all of these instances, and the second chart will give us counts for them. And so this is to help you track down memory leaks. If you had a particular spike in any of these or some growth over time, you could then take some action on that. This is, again, still very much a work in progress, so we're kind of getting the data out there and then seeing what people want to do with it. Yeah, you can see here, code, array, string, closure, sizes for all those. And then this piece, which is the new counts piece, which is going to be extra buggy because it thinks there are some negative values for some of those. But like I said, work in progress. So that's the heap instance stuff. We talked about alerts. The errors stuff, I don't have anything to show on there right now because it was working this morning but just is not working right now. It's going to be an error log. We're going to be tracking all the errors that any application throws, and we're just going to have a log on that. We'll put a chart up as well too on the dashboard to show how some of that trends over time. And yeah, that's the dashboard that we've got. I thought I had more, but the alert stuff was going to be a bit more, so I apologize for that. Any questions? What else can I say about this? Okay, it's about half the time I wanted it to be, but yeah, if there's no questions, then I'll call it. Thanks.